In this last part of the section 4.5 notes, we're now going to look at what's called function notation. Because every equation is not always written in y equals form. If the equation represents a function, then we can actually write it in another form, and that's this, where we have an f and an x in parentheses. We call this function notation. The idea is that saying y equals is the same thing as saying this fx equals. And this is actually read f of x equals. Okay, that doesn't mean f times x, which normally when you have two things kind of smashed up against each other without an operation in between, it's actually read f of x and then the equal sign. And typically then you'll see some other things on the right hand side of this equals still involving an x. So you might have something like x plus 5 over here on the right. What this really means, why do we have this separate notation, this f of x notation? Really what it is, it's saying that this equation isn't just an equation, it's more specifically a function. Meaning it only has, it doesn't have those repeating x values. For every x value, there's only one corresponding y value. So what that means is that y is a function of x. Sometimes you'll see it written that way. It means that your y values, y is a function of x. All of your y values depend upon what x values you put in. So they kind of, writing f of x is saying that y is a function in terms of x. It all depends on what x values you're plugging in. Okay, so that's kind of a basic idea of what function notation is. And so you'll see this f of x notation, sometimes it's not even the letter f. We can really use any letter we want to name a function. Just most often we use the letter f. So going to the next page, the last page of these 4.5 notes. Let's bring this down here. We have the example f of x equals 9x minus 5, and you are asked to find f with a negative 2 inside of parentheses. So first things first, move this down. F of x equals 9x minus 5. Remember we just said this is the same thing as saying y equals. So f of x equals 9x minus 5, same thing as saying y equals 9x minus 5. No difference there. Find f negative 2. This would then be read f of negative 2. Okay. So you're being asked to find. Well, I guess let's talk about what is this asking us to find. The x in this function notation was replaced with a negative 2. What it's asking you to do is find the value of the function, okay, what is the y value when we use an x value of negative 2. So it'd probably be good to write that down. Means find the value of the function in other words, what is the y value when we decide to use an x value of negative 2. So, if we're trying to find f of negative 2, and a lot of times you'll see the word, write this in here, evaluate. Rather than find, they might say evaluate f of negative 2. Okay, this is what they're asking you to do. Just plug in negative 2 for x. So in our equation, we have y equals 9x minus 5. So 9, replace the x with a negative 2, minus 5. Wherever we were to see an x, we want to replace that x with that value, that number. So here, 9 times negative 2 would give us a negative 18. And then negative 18 minus 5 gives us a negative 23. So f of negative 2 equals negative 23. So since we're saying f of negative 2 equals negative 23, this implies that y equals negative 23 if we choose an x value of negative 2. So that right there, technically your answer would be this right here, negative 23. What is f of negative 2? It's negative 23. But a nice thing about this then, I guess what this is telling us is graphically we could make ordered pairs out of this. Since we chose a y value of negative 2 and the result an x value of negative 2 and the result was a y value of negative 23, that tells us if we were to graph this function, the ordered pair negative 2 comma negative 23 would be on that graph. And that's a linear equation, so it would be a line. So the point negative 2, negative 23 would be somewhere on that line. Okay. So now looking at our next example, we have another function. This one's not labeled as f, it's called g. Okay, so we're calling this function g of x. It doesn't really matter what letter's out in front, it's just a letter giving that function a name. So our g of x equation is g of x equals negative x squared plus 5x minus 3. This equation has an x squared in it, so it would be a parabola, it would be a quadratic equation. Although that doesn't necessarily matter in what they're asking us to do here. So here, part A, we're being asked to find what is g of 4. In other words, what would we get for a y value if we plugged in 4 for our x value? Now here's where you want to be careful, and I would suggest anytime you're plugging in an x value into a function, you always put it in parentheses. And an example like this really demonstrates why. When you have negatives, it's really easy to throw off your signs. So throw the 4 in for x in parentheses there, so negative, then 4 squared, plus 5x, so 5, put the 4 in parentheses there, minus 3. So this problem's a little different. We had two spots we had to plug in the 4 for x. Okay, going ahead and doing this piece by piece. Order of operations would tell us we have to square the 4 first to get 16, and then apply the negative. So this would give us a negative 16. That's why I said you have to be careful. If you looked at this as a negative 4 and did negative 4 times negative 4, when you squared it, that'd give you a positive 16, and that's not correct. So there's an easy way to make a mistake there. 5 times 4 here gives us 20. Bring down the minus 3. Combining those three numbers, negative 16 plus 20 minus 3 gives us negative 1. So once again, that would be our answer. Or excuse me, that's a positive 1. So that would be our answer to evaluate g of 4. What is g of 4? It's just 1. Our y value would be 1 when we plug in an x value of 4. Okay. Now part B to this same example, a little trickier, we're given a variable. Find g of a is how we would read that. But it's kind of same process we were doing above. If we're replacing inside the parenthesis, we're placing x with an a, then inside wherever in our equation wherever we had an x, we replace those x's with a's, just like we replaced them with 4's in the part A above. So, no big deal, let's just replace all our x's with an a. So minus x squared becomes minus a squared plus 5x plus 5a minus 3 minus 3. At this point, if you could combine any like terms, you want to do that, but an a squared term and a single a term, those are not like terms, we couldn't combine. And then a number by itself without any variable attached is not a like term. That's all we can do in that problem. So negative a squared plus 5a minus 3 would be our final answer there. Okay. So that maybe makes it a little trickier when you throw variables in it. It can get even trickier with variables, and that's what our next example is. Let's take a look at that. Okay. So we have a new function here. We're calling this new function h of x. Let h of x function be equal to 2x plus 3. Find h of q plus 1. So that might be even more tricky, I'm assuming, for most of you. Maybe for some of you that looks really confusing, but let's take a look at it and hopefully this will clear it up. So we're replacing the x with a q plus 1 inside the parentheses. So what this means is, in our equation on the right hand side of the equals sign, wherever we had an x, we need to replace it with q plus 1. So 2, and here again you definitely have to put q plus 1 inside a parenthesis. And then bring down the plus 3. That was already part of the original equation. Reason why you have to put in parentheses, it reminds you you're distributing the 2 into both terms. Because this is saying 2 times x, whatever x is. So if x we're replacing with q plus 1, we need to multiply 2 times that whole value, q plus 1. So then distributing the 2 into that parenthesis, you get 2q plus 2. And then bringing down the plus 3. So last step, combine the 2 plus the 3 gives us 2q plus 5. And that right there would be your final answer, because you cannot combine the like terms anymore. There are no more like terms to combine. So h of q plus 1 is equal to 2q plus 5. Alright. And now finally, our last example here, we are given a mapping, and we're giving a set of ordered pairs. And you're being asked for these two different examples. This is like problem A and problem B. Evaluate, find what is f of 3. Okay, so if you go back to the definition, what are we doing when we're finding f of 3? We're saying when x is equal to 3, what is our associated y value? Okay, so looking at the mapping over here on the left, if you recall, with every mapping, this left circle bubble represents our x values, this right circle represents our y values. So when our x value is 3, our associated y value is 5. So that tells us f of 3 is equal to 5. So your answer in that one is just 5. Once again, that tells you, on the graph you would have the ordered pair 3, 5. But just evaluating f of 3, your answer would just be the number 5. Then looking at our example involving the ordered pairs, well, we need to find the ordered pair that has an x value of 3, and then you look and see what is the associated y value. So negative 3, 5, well, that's not positive 3, so that doesn't work. 0 is our x value, that doesn't work. 3 is our x value. So if 3 is our x value, the associated y value with that is 1. So that's the ordered pair we need to consider. And so for this example, evaluating f of 3 would be the y value of 1. So with a mapping or a set of ordered pairs, a little bit easier. You can really quickly just come with the answer. You don't really have to evaluate anything like we did up here. And that finishes up section 4.5.